Hello everybody, it's Mario, and today we're looking at my full lens distortion workflow. I don't know how correct it is, but I use it on everything I work on, and I haven't ran into any problems. So the basic idea is we are going to 1. Undistort the footage with either a camera solve or a lens grid. 2. Set up a CG workspace for that undistorted footage. And last, 3. Redistort all the elements back to the original plate. It's really that simple. Probably throw in some extra stuff in there, but let's just go ahead and start. Alright, so let's go ahead and start with the first method of getting lens distortion information, and that is with the camera solve. So in Nuke, I just dropped a camera tracker on here, and I did a solve, and then I ended up with this. And one of the cool things you can do in Nuke is go to the Export tab, Undistortion, Create, and there we go. Let me go ahead and look at it and show you before and after, and everything looks good, and it seemed to calculate the lens distortion information pretty well. So yeah, this is the first way you can get lens distortion information. You just have to make sure that your camera track is good. Otherwise, you'll get some pretty weird results. Usually you can look at the undistort and then tell if it is correct or not. Right now, everything looks pretty correct. Like this bowed little line right here kind of straightens out. And yeah, it just seems like this is correct. I haven't really tried in Fusion or After Effects, but I'm sure that there also is a lens distortion kind of output from your camera tracker. So yeah, this is the first way to do it. So let's go ahead and look at the second way real quick. All right, so here is the second way to get lens distortion information, and that's with a lens grid. So if I look here, this is a lens grid. This footage right here is exactly the same settings and camera and lens as the previous shot that you just saw. It's just a different shot. That's pretty much the only difference, and the exposure is different. But yeah, what I did is I shot a plate with this, and instead of getting the distortion information from the camera tracker, I just went ahead and I shot a lens grid. So if I look here, you can see there's this lens grid. So it's just video. It's same exact lens, same exact settings as the footage here. It's just I'm shooting a lens grid instead. Now, if you're wondering how I got this lens grid, I literally just typed in checkerboard into Nuke here. I upped the resolution, something like that. I full screened it like this. I aimed my camera at my computer screen and I recorded it. And that's literally exactly how I got this. You can see my mouse right here. It's kind of funny. So yeah, that's all you really need to do this step. So the next thing I did is I just brightened it so it was easier to see. And then in Nuke, we have this cool little node, lens distortion node, where we can hook it up here. We'll go ahead and look at it. Go to the analysis tab here, hit detect, and it's going to detect the lines in the checkerboard patterns. And if you hit solve, boom, it's able to get a really accurate lens distortion calculation because it's just looking at straight lines here. So it's looking at this checkerboard and it knows that these should be straight on the Y and the X axis. Yeah, so that's the two ways that I actually ended up getting this undistortion information. And as you can see, they're pretty similar as in their bounding boxes and how much they're being undistorted. So yeah, everything looks good to me. Now you probably already are noticing a problem, and that's obviously that there's information being cut off. Like if I undistort this, there's information out here that's being cut off, and then obviously with this one as well, being cut off. So that's what we're going to deal with next. If you try to bring this into CG, you're going to be missing out on all this information out here. Let's say in your CG you need to have some interaction over here on the edges, but this gets cut off, then you won't be able to see what you're doing, what you're working with. So what we need to do is actually add resolution. Now, if we go into the lens distortion node, there's all these settings in order to add resolution and do the thing that we're going to do. I'm going to do it a more manual way, just so that everyone can follow along easier. And it's actually what I do anyway normally. So what I'm actually going to add is a reformat node here in Nuke. I'll show you real quick in Fusion too. I don't use Fusion often, but I just want to show what this step would look like in Fusion, just in case that's what you're using. All right, we're going to change this to scale. I'll go ahead and just check preserve bounding box. I don't think it's necessary, but we'll put that on, and then resize width to none. Resize type to none. And what I'm going to do here is just add resolution. So we're going to go 0.1, 0.2, and this seems to be enough resolution. Let me go ahead and add a crop beforehand. Yes. If we look at all the edges, we can see that this is enough resolution to encompass the whole shot inside of the bounding box. So as you can see here, nothing is getting cut off anymore. everything fits inside, but now we have a new resolution. If you look down here, this is the new resolution. So if I turn everything off, there's our old resolution, which is the camera resolution, 1920 by 1080. Turn everything on. This is our new resolution, and this is just so it could fit everything inside. So we'll go ahead and jump on over to this shot right here, and you'll see it's exactly the same thing. I'll just go ahead and type in reformat. And this is the lens grid version. Preserve bounding box, resize type to none, and scale. And if we go ahead and add resolution here, you'll see 1.3 actually seems to be what we need in order to fit everything inside. I'm going to add a crop beforehand. And this crop is just to get rid of these stretched pixels, because what it's doing is this isn't actually the plate. This is stretching pixels. So if I crop beforehand, it'll make all of these, it'll get rid of the pixel stretching and only show what is actually the plate and not extended edges or anything like that. And as you can see here, we are fitting everything inside. You might have noticed that I'm not using crazy decimal points. Like I'm not going like 1.200149 or something like this. I'm just keeping it very simple, because this will actually be helpful throughout the process to keep these numbers as simple as possible. So that's why I'm just going in these big increments. So I'd recommend that for you too as well. Otherwise it can get a little more complicated. All right, so now that we are at this new resolution, you're actually going to notice a problem. So let me just demonstrate that here. I'm going to go ahead and create a scene. So this is just a 3D scene, just a nuke. And I'm going to go ahead and use a point cloud from this camera tracker. Go ahead and connect that up there. And you can see I made an undistort node, but I'm just going to use the one that we just made right now for easier demonstration. So let's go ahead and drop that in there. And if I look at this, everything seems to be working fine. Even if I remove this, let me go ahead and remove, you'll see this is a point cloud. So this is actually not the footage, this is a point cloud from the camera solve. And yeah, everything is matching up really well. So we're looking good, but that is only before we started fitting the resolution in here. So once I go ahead and I actually switch to the version where we added resolution, like right here, and we go ahead and look at it, they're not matching anymore, right? Let me go back. Matching? Not matching anymore. So of course we actually need to fix this, because adding resolution is changing the framing, meaning the CG is now not matching anymore. And this is actually a really easy fix. So the way to do this is you want to take whatever resolution that you had in here. We added 1.2 times the amount of resolution, and we're going to go into the camera. Go on over to focal length. I'm going to go ahead and add an expression. And I'm just going to say whatever the value is, divide that by 1.2. So like I said, we added 1.2 times the amount of resolution. Now we're going to divide by that same number, 1.2, in the focal length. Just hit OK. And let's go ahead and look at the CG and see if it's matching now. Boom. As you can see here, matching perfectly. And if I go ahead and remove the footage, yeah, you can see matching perfectly. Now, you might have saw that I added an expression, but that's just because sometimes the focal length can be animated, but it works just the same even if you were to go in here and say do no animation, and we just literally did the math here. So we just do divided by 1.2, hit enter, and it does the math correctly. Or if you don't have the ability to do that, then of course, you know, just grab a calculator, type in this number, then type in, paste that in, divide it by 1.2. There you go. You have this new number. Copy that, paste that in here. Boom, there you go. So just a lot of different ways of handling this. The expression is just my favorite way of doing this. So I'll go ahead and add this back in, 1.2. And this is why I keep this number simple, is just to be able to do that really well. So yeah, if you end up adding resolution that wasn't in the actual camera solve, then this is a step that you're going to need to do. So we tracked at 1080 and ended up at a higher resolution, which means that we're going to need to do this fix where we fix the focal length. Pretty much the only time that you will not be doing this focal length step is if you, like me, for some reason on this shot, undistorted your footage like so, added the resolution. So as you can see here, we added the resolution, and then you track that added resolution, the plate with the added resolution. So if you look here, I tracked this added resolution version, then that's the only time that you don't need to do this focal length thing. I hope it's not too complicated and that you get it, but if you're having a difficult time, once you start doing shots and just practicing, I think it'll make more sense. Oh, and just to show you for Fusion users, in order to add resolution, you wouldn't use reformat. You would use, if I jump on over, you'd actually end up using the crop node right here. So I added a crop. I'll go ahead and connect this right here. I'll look at it. Let me go ahead and show the bounding box because this is kind of weird for me to look at. Yeah, so you add this crop node. We're going to go ahead and look at it. We're going to turn on keep aspect, keep centered, and then right here, this is where you would add the resolution. So I'm going to do what I did over there, which is to multiply by 1.2, hit enter. And there we go. It added the right amount of resolution. And let's say that wasn't the right amount. You would just reset this and then try 1.3 and then so on and so on. But I ended up using 1.2. So yeah, you literally just type in times 1.2, hit enter, and it does the math for you. And it's the exact same thing. The only difference is I think Nuke doesn't show checker. Yeah, it doesn't show that checkerboard. But yeah, see if I type in 1.2, it looks like this. And if I jump on over to Nuke, 1.2, exactly the same thing. So you can see right here. Okay, so now that we prepared everything correctly, we can go ahead and just, you know, render this out, and we'll jump on over to whatever 3D package you want to use. Okay, so I've launched Blender, and I just opened one of the shots just to demo what it would look like to bring this into CG. So what I did is I exported out of Nuke the corrected focal length camera. So I corrected it in Nuke and I brought it here, but you don't have to do that. You could just export the original camera and do the same thing here. So I believe it was like times 1.3 or something like that. So you could literally just do it in here just in case you're not able to do it in whatever application you were in. So see, works just exactly the same. Most of the techniques I'm showing here are pretty software agnostic. So yeah, I have the corrected focal length camera in here, and I have the rendered out undistorted footage at the new resolution. So this is the higher resolution version. And I need to make sure to set those settings here. So if we look down here, our overscan, our new resolution is this right here, 2400 by 1350. So that was after doing the reformat stuff that I was talking about. And if we look here, 2400 by 1350. At this point, you really can just start working. So now your CG workflow will work well. You don't need to worry about all this overscan. I have a plugin here for overscan. With this workflow, we're completely ignoring that. So we're not touching any overscan. We're not doing anything like that. It is not needed. We already handled it. So don't even worry about this. Don't even pay attention to it. It's not really relevant to us at all. So yeah, as you can see here, I just went ahead and I took a scan and I aligned it in here. And then I went ahead and kind of retopoed some more like easy to look at geometry. And I just animated. And this is just to give a little bit more of a real world situation where I would use this. So I just dropped in this model I found online. I went ahead and just rigged it, did a quick little texture and animation, just enough to get like a more realistic demonstration across instead of just adding like cubes or something in here. But yeah, nothing about the workflow really changes at this point. Once you got it set up, then you're pretty much good to go. And you can render at lower resolutions, anything that you want here. It doesn't really matter. No matter what resolution that you lower this to, we're just going to go ahead and reformat it back up to this resolution anyway. So now just work the way that you'd like and go ahead and export. I'm going to go ahead and render this, and we're going to call the CG side of this done. So let's go ahead and jump into Nuke with all the renders that I have. All right, so the render is done, and this is what it's looking like right now with all the redistorts and everything applied, but I'm going to go ahead and just walk you through. It's not complicated, but just how to redistort your CG. All right, so I'm gonna make this really simple. All we're doing is redistorting any overscanned elements. It's literally that simple. Anything overscan, you apply distortion to it. So what is distortion? Well, it's the inverse of undistortion. So I'm gonna go ahead and take the elements that made up our undistortion. I'm gonna plug them into the plate because this is just the best way to show exactly what I'm trying to say. All right. So this is all the steps that we did to get here. This is how we got our undistortion, right? We already know how we got here. So if redistortion is the inverse, we're literally just gonna go backwards now. So instead of undistort, reformat, now we're just going reformat, undistort, all right? And we're just gonna flip the values in here. So now that these are mirroring each other, we need to change their actual settings so that they're actually the inverse. So I'm gonna go to the reformat first here. We're gonna go in here and whatever the number is right here, we're just gonna add a 1 in front of it, divide, and there you go. See, 1 divided by whatever the number was right here, hit enter. There we go, it gave us the inverse. So that's how you get the inverse. And the reason it's division is because that's the opposite of multiplication. All right, and now we're gonna go into the lens distortion node. Click in here, I'm gonna open it up. And instead of undistort, click it, redistort. Now you can see like the edges right here are kind of stretched out and stuff, but that's just a bounding box issue. So we'll just go to the bounding box here and change it to input. There we go, it fixed everything here. And as you can see, it's that easy. It's not any harder than that. It's literally the opposite of undistortion. So we did our undistortion there, did our distortion here, and just to show you, these are exactly the same. So if I go to the plate and then I go to our little setup here, exactly the same thing. So that means we are reversing everything correctly. And the only differences you'll see is that it's a little bit softer, as you can see here. But that's normal. That's just because of the filtering in here. So now that we've done this little setup so that we can make sure it's working, this is a good way to troubleshoot, is to just do it on the plate. We're just going to go ahead now and just take our little, this is our distortion section. We're going to copy that and we're going to go on down here. And just for demonstration, I'm going to delete the one I already have and I'm going to paste it in here like that. Now if we look here, our elements are redistorted on top, and I could actually turn them off, and you could see not matching because that's overscan format. Now it's matching, and then here's the distortion by itself. You can just turn it off and on, and there you go. Our elements are distorted correctly, and it's really not harder than that. Okay, so I want to show you something. In my case, I actually rendered at full resolution. So that just means that I rendered the full overscan. I didn't down res or anything. And again, just to show you, that just means I rendered at 100% resolution. I didn't do any downscaling or render at lower resolutions or anything. But let's say to save resources, you rendered at say 40%, right? And it can be any number. I'm just choosing 40. So let's just go with 40, but it can be any number. So when you render this out, you're actually going to end up with a lower resolution. Do not add this node. This is just me pretending, but I'm going to pretend that this was rendered at 40%. So I'm just adding a format, scaling this down to 0.4. That's 40%. Okay. All right. So we'll pretend this is our raw render and it is at 960 by 540. Well, I'm just going to add a reformat. And one way you can do it is in here, there is literally a way to select the exact resolution you want. So over here, I have an overscan resolution. I click it and it scaled it up, see? So the resolution is now correct, as you can see right here and right here. Or for some reason, if you just felt like making it a little harder on yourself, you can do the same thing, just add a reformat, but instead choose scale. And whatever you chose here, 40%, we're just gonna go ahead and do 1 divided by 40%, which is 0.4. Hit enter, and there you go. You could see now it's the correct resolution. So really my point here is just make sure that the render coming in is the correct overscan resolution. All right? So if you ended up down resing, just make sure that you are scaling up to the correct resolution. Yeah, so that's the only gotcha that I'm gonna go over. Let's remove these. Now, I showed you everything today with Nuke, but these concepts apply to any of the software. You can do all these steps in any CG software or compositing software that you have. And that's why I like doing this workflow. This shot here, I actually ended up tracking with Meshroom. So in Meshroom over here, I just did a regular scan, but that also includes cameras with it. All I did was I just went over here and I went to export export animated camera node right here, hooked up dense SFM data into here. I just went ahead and went with these settings. So I exported UV maps, exported undistorted images. I made sure this is EXR, which is extremely important. Don't use JPEG for this. And I exported full ROD left principal point on. Right clicked, I hit compute, and that is literally what you see here. So I just imported the alembic file. So if you look right here, this is the alembic that it creates. So that's in here. And then this thing that says UD right here is literally the undistorted plate that it creates. So if I open this up, you can see those two right here. So this is the Meshroom folder. That's the camera alembic it created. And then here's the undistorted images that it created. And as you can see here, it just did the undistortion step for us. So this is the original plate untouched. And here is the undistorted plate. And if I look at the scan that it created, so yeah, this is actually a scan. Yeah, if we look at this scan that it created, as you can see, if I zoom in, this is actually fully a scan. You can see that projected the texture of this box onto the pillar there. They're matching up exactly. So yeah, if I look before and after. But again, we run into that problem where there's extra information out here on the edges that is getting cut off. Same exact workflow. And even though I'm using a different software, not much really changes. So again, I'm just doing that reformat thing, preserve bounding box, resize type to none, scale. And then I'm gonna go ahead and type 1.1, not big enough, 1.2, not big enough, 1.3, that's big enough to encompass it. And then of course, we're gonna have to do the focal length thing because now you can see they're not matching, but I just go in here, projection, add expression. And what number was it again? 1.3, I believe. Yes. So we divide by 1.3. There we go. And now matching perfectly the scan and the undistortion. And it doesn't really matter what frame we go on. They are both matching perfectly, as you can see here. And of course, we just do the opposite in order to do redistortion. So in this case, Meshroom actually exports an ST map instead of like a lens distortion node or something like that. I actually don't end up using this undistort map it creates, but let me go ahead and import both and show you why real quick. I actually don't use this UV map undistort just because if I apply it to the plate the way that you're supposed to, ST map, plug that in. I believe this is the texture node in Fusion also. Plug that in, and then I just choose the right channel, RGB. You can see that it actually cuts off the edges here. There's no overscan, so if I were to do this reformat thing on it, you see the edges are cut off, and I don't really feel like figuring out how to fix that or anything. So that's why I just use undistorted images that Meshroom exports instead of using an ST map. So yeah, I'm gonna get rid of that undistortion. But let's get back to what we were doing, which is to redistort. And how are we gonna do that? We're gonna do the exact opposite of what we just did. So in this case, we have undistortion, reformat. We just duplicate this, do that thing where we make it opposite. So 1 divided by whatever this is. Okay, gets rid of the resolution. And then last, we need the ST map. And this is literally just our redistortion. Let me go ahead and add RGB. And there we go. We just did the opposite of what these two operations did. So this was undistortion, redistortion, and it's really that simple. And if I look at the plate and I look at this, you can see exactly the same, besides that they lost a little bit of quality. As you can see here, kind of blurring, but that's expected. So yeah, I hope this helped you. If you have any questions, let me know. I do want to inform all the people that keep asking that I actually am going to do a transformer tutorial. It just isn't done yet, so that's why it's not released. But when I have time, I work on it. And yeah, that's all I really have to say. Hope all your visual effects projects go well, and goodbye.